In 1979, mobile networks already existed worldwide. They operated on different frequency bands and adhered to different standards. A mobile phone in the USA could not be used in England because British and American mobile phones and networks had their own standards. They utilized different protocols, different signals, and different technologies compared to each other. GSM Global System for Mobile Communication was not commercially in use in 1979. Its development began in the early 1980s as European telecom providers and regulators aimed to establish a unified digital mobile standard. At that time, mobile communication were mainly reliant on analog systems and the concept of the standardization digital system was still being discussed. The GSM standard was finalized later in the 1980s, leading to launch of the first commercial GSM network in 1991 by Radiologia in Finland. No country had implemented a GSM system by 1979, as it had not yet been developed or deployment. ETSI, European Telecommunication Standards Institute, was founded as an independent non-profit organization aimed at developing standards for rapidly evolving telecommunication and ICT, Information and Communication Technologies sector in Europe. Its establishment was a response to the necessity for unified standards to support the expanding digital and mobile communication infrastructures across the continent. GSM 900 frequency. GSM 900 frequency, we have downlink frequency 1890 between 1819 to 9015 megahertz, and the uplink frequency is 90 35 90 60 megahertz. Downlink frequency is the frequency is used for communication from the cell tower to the mobile device, and the uplink frequency is used to communication from the mobile device to the cell tower. GSM 1800 megahertz. We have a downlink frequency 1710 megahertz to 1785 megahertz, and the uplink frequency is 1805 1880 megahertz. And 19 megahertz. The downlink frequency is 1850 megahertz and 1910 megahertz, and the uplink frequency is 1930 megahertz, between 30 to 1919 megahertz. GSM offers several advantages over the traditional public switch telephone network (PSTN). Key features and advantages of GSM technology. An overview of GSM capabilities and benefits. The first is mobility and roaming. Wireless communication. Designed for users to make and receive calls while moving. International roaming. Enable mobile device usage across multiple countries seamless. Efficient use of resource. Digital technology. Utilize technologies like time division multiply access (TDMA), frequency division multiply access (FDMA), Spectrum efficiency. More efficient use of available spectrum compared to traditional circuit switch, public switch, telephone network (PSTN). Enhanced service beyond voice calls. Support text messaging, SMS, data service, and multimedia messaging. Digital signaling facilitates additional services such as email, internet access, and mobile applications. Improve quality and security. Voice quality. Digital communication offers better voice quality and noise reduce compared to analog system. Security features. Built-in encryption enhance security, which is often lacking in standard PSTN channels. Cost and infrastructure efficiency. User capacity. GSM networks can support more users in a given area than PSTN infrastructure, potentially lowering operation cost. Flexible network topology. Digital switching allows the enhancement scalability and flexibility in network management. GSM handovers. We have intercell handover occurs when the mobile device moves from one cell to another. This can be further device into the. I mean, this mobile is servicing in this cell and it will hand over to the another cell. Intra-cell handover occurs when the mobile device moves to different frequency, F1 to F2, like that. Within the same cell. Hard handovers. Hard handover, the connection to the current cell is broken before or the connection to new cell is establishment. This can momentarily interrupt the call. Soft handovers, the mobile device maintains connection to both current and new cell simultaneously during the transition, reducing the risk of call drop. Handover process. We have measurement reports. The mobile device continuously monitors and signal quality of servicing cell and neighbor cell. It sends measurement reports to the base station. Handover decision. Based on the signal quality and the predefined criteria, the network decision whether a handover is necessary. Third is preparation for handovers. The network prepares the necessary resource in the target cell and establishment connection. Execution of handovers. The mobile device switch to the new cell, either to the hard or soft handovers, and the call or data session continuously without significant interruption. Handover completion. Once the handover is successfully, the handover released the resource from the previous cell. Theoretically, maximum range. Ideally condition, the maximum range of GSM can theoretically reach up 35 km in ideal condition. This means clear line of sight communication without scientification obstacles like buildings, hills, or trees that could attenuate the signal. Frequency impact. Low frequency band like GSM 900 MHz can cover larger distance compared to higher frequency band like GSM 1800 or GSM 1900. This is because lower frequency tend to have a better propagation characteristic and can penetrate obstacles more efficiently. In practical terms, The lower frequency, the better coverage, and higher frequency generally provide greater capacity, but less coverage for GSM. This is why 900 MHz can achieve longer ranges compared to 1800 MHz or 19 MHz. Practically, consideration in practical deployments in effective range is usually less than the theoretical maximum due to environment factors. Typically, range for GSM are often between 5 km to 15 km, depending on the specific deployment condition. GSM sectorization. Omni sector, you can see now omni sectors antenna that radiate and receive radio frequency RF signals in all horizontal directions, like this. Simulation. They are designed to provide 360 degrees cover around the antennas. It will cover 360 degree cover around the antenna, making them ideal for situation where the coverage needs to be provided in all the direction from the single points. Key characteristic for omni sector: 360 degree cover. Unlike the direction antenna that focus their signal in a specific direction, omni sectors distribute their signal evenly in all directions around the antenna. Vertical polarization. Most omni antenna are vertically polarization means that electrical field or radio wave is perpendicular to the ground. This is common in mobile communication. Gain and range. The omni antenna typically have lower gain compared to directional antennas because their energy is spread out over a large area. This results in a shorter range but broader coverage. Applications. They are commonly used cellular base stations in rural or suburban areas where 360 degrees coverage is needed. Wi-Fi hotspot where coverage needs to be provided in all directions. Marine or aviation communications where an all-around signal is beneficial. What is a directional antenna? A directional antenna concentrates its signal in one more specific directions, creating a beam or lobe radiation. This result is higher gain and longer range in the direction the antenna is pointed but reduced or no coverage in other direction. Key characteristics of direction antenna. Radiation pattern. The primary characteristic is a direction antenna is focused radiation pattern. Common patterns include signal main lobe. For example, in Yagi antenna or multiple lobes sector antenna. Gain. Directional antenna have higher gain compared to omnidirectional antennas because they concentrate their energy in specific direction. This result is stronger signal and longer range in the direction. Polarization. Directional antenna can be either vertically or horizontally polarized, depending on specific design and application. Applications. They are commonly used in point-to-point communication links, such as between two buildings or towers, cellular networks to cover specific areas. Wi-Fi networks extending coverage in a particular direction. In summary, the directional antenna are specified antennas that provide focused coverage in a specific direction. They are particularly useful in scenarios where coverage is needed along a specific path or between 2 points, and they can offer advantage in terms of signal interface. However, their use should be carefully considered based on the specific requirements of the coverage area and the potential limitation in coverage. Base Station Subsystem (BSS). This subsystem handles the radio interface between the mobile phones on the networks. NSS Network Subsystem. This subsystem handles call switching, mobility management, and subscriber data. Here we observe two distinct base station subsystems (BSS) interconnected within the network subsystem (NSS). A call between BSS to uh, to BSS is routed. PSTN standard public switch. Telephone network is the traditional telephone system in the network of wireless of switch that connect to landing phones worldwide. The diagram illustrates the path a call takes between base station subsystem BSS and public switch network PSTN through the PSTN. Operation Maintenance Center (OMC) is a facility responsible for monitoring and management and controlling. A telecommunication network (OMC) use sophisticated software and hardware to oversee the performance and the network, identify and resolve faults, and proactively manage network resources. They are crucial for ensuring reliability and quality of service for telecommunication networks, including mobile networks and fixed line networks. Base Station Subsystem (BSS). This subsystem handles the radio interface between the mobile phones and the networks. Base Transceiver Station (BTS). The physical radio equipment cell tower that communicates directly with mobile phones. Multiple BTS are controlled by a signal BSC. Base Station Controller (BSC) manages and controls multiple BTS within a geographical area. It handles radio resource allocation, handover between cells, and other radio-related functionalities. BTS is a transmission and receiving unit. So that why the vehicle is named is transceiver. This makes the connection with mobile station via the interface and controls. The transceiver and transceivers is central unit of BTS. Frequency holding maximum 8 users. Totally 8 users. BTS also responding for the monitoring and signal quality, encoding, monitoring, and modulation of signal. Radio communication. The BTS handle radio signals and are transmitted to the received from mobile devices. Connection to the network. The BTS connection to the base station control to BSC signal processing. The BTS performs the various signal processing tasking, including modulation, demodulation, to ensure clear and reliable communication. Frequency management. It manages to radio frequency used to communication, ensuring and channels are allocated efficiently to avoid interface between users. Handovers. The BTS plays a role in managing handovers, which occur when a mobile device moves from the one cell cover to area to another, ensuring seamless transition without dropping calls or data session. Type of BTS. There are different type of BTS depending on the technologies used, such as GSM BTS, UMTS BTS, I mean Node B for 3G, and E Node B for LTE. Each type of specific functionalities and capabilities. It connects to base station control. It connect to the base station control. I mean BSC. BSC base station controller. BSC. We call BSC. The radio resource management. The BTS manage the radio resource, including allocation and deallocation channels, managing power control and handling interface. BTS assign free radio channels to link to the mobile station. Power control. It manages the power levels of BTS, ensures to optimal signal quality and minimize interference with other cells. It controls necessary output power with mobile station to the TRX. Handovers. The BTS handle handover which occur when a mobile device moves to one cell to another cell. BSC has some functionality like interface management. The BTS manages the interface, ensuring that network provides the required level of service mobile devices. Network management. The BTS manages to network including monitoring performance, detection, faulty, and taking correction action. Security management. The BTS manages the security including authentication and authorizing mobile device, encrypting and data, and detecting and preventing security threats. NSS, Network Subsystems. The network subsystem NSS is the core of mobile network responsible for managing calls, subscriber data, and various network functionalities. Unlike the base station subsystem (BSS), which handle radio communication to the NSS handles the logical aspect of the network. Mobility management, tracking the location of mobile phones and managing handovers between cells. Authentication and security, verify the user identify and security communication. Switching matrix. The switching matrix is the core component and the MSC, mobile switching center responsible for switching traffic between different ports and networks. Call control process. The call control process manages the all call setup, tear down, and handovers, as well as mobility management and service control. Signaling process. The signaling processor handles signaling traffic between different networks and services. Database. The database stores information about mobile device, including their location, subscription details, and service profiles. As you can see in figure 8 time slots in BTS level. There is a 8 time slot, as you remember, in BTS site, each TRXs. And 4 time slots is 4 packages in the ABC interface goes to one time slot, and this 4 time slot packages goes to in ABC interface in the second time slot, like that. In the picture here, each time slot on the ATAR is placed in a way that each time slot is distributed on A interface, like first, second, third, and fourth time slot goes to the one time slot, each time slot, like this. We have 31 time slots for the ATAR and A interface. Why we use like this in transcoder? Because of the GSM network is very new technology, and the after MSC and the PSTN technology is the oldest technology. So we will keep our equipments to this reason. MSC, Mobile Switching Center, MSC. MSC standard for Mobile Switching Center. Its crucial components in mobile networks subsystem NSS, acting as the central switching point for calls and other network functions. Think of it as the equivalent of telephone exchange, the traditional landline network, but for mobile phones. As the picture shows, the mobile switching center calls both incoming and outgoing calls. Call switching. The MSC routes call between mobile phones connecting to them to each other or to the public switch telephone networks (PSTN), allowing to you call handling and vice versa. The mobile switching center (MSC) doesn't just passively route calls; it actively monitors and controls them through their life cycle. This monitoring and control involves several key aspects. Monitoring call status monitoring. The MSC constantly tracks the status of each call from initiation to termination. This includes monitoring for drop calls and failures and other anomalies. This data is crucial for network performance analysis and troubleshooting. Resource usage monitoring. The MSC monitors the usage of network resources such as bandwidth and signaling channels. This helps in optimizing resource allocation and preventing congestion. Quality of services (QoS) monitoring. The MSC monitors the quality of calls, including factors like latency and bit errors, something like that. This helps ensure that calls meet to record the quality standards. Security monitoring. The MSC monitors calls for security threats such as unauthorized access to attempts to compromise the network. Call routing control. The MSC is the central point for routing calls, determining optimal paths for a call to take based on factors like network congestion and availability of resource. Call setup and terminating control. The MSC initiated and terminated calls coordinating with other network elements to establishment and disconnect connection. Handover management control. As a mobile phones moves between different cells to MSC manage the handover process, ensure that call remain in connection without interruption. This involves coordinating with the base station controller, BSC, and other network elements. Congestion control. The MSC implemented condition control mechanism to prevent network overload. This might involve rejection, new calls, or prioritization existing calls based on their importance. Call admission control. The MSC decides whether to accept a new call based on available resources and network condition. Security control. The MSC enforces security policies such as authentications and encryption to protect calls from authorized access and robbing. Base station control (BSC). This is the primary connection, the MSC communication with BSC to manage calls and handovers between cells. The A interface is the standard protocol for this connection. Location register (HLR). The MSC interface with HLR interactive subscriber information such as the subscriber service profiles and current location. Visitor location register (VLR). The MSC interacts with VLRs to manage the location information of roaming subscriber within its area. Authentication Center (AUX). The MSC works with the AUX to authenticate users and generate encryption keys to secure communications. Equipment Identifier Register (IAR). The MSC consent AR to verify the validation of network device and prevent the use of stolen or blacklisted phones. Other MSC. MSC connect to each other's route call between different geographical areas. Serving GPRS support nodes, SGSM, and gateway GPRS support, GGSM. In GSM network supporting GPRS, General Packet Radio Services, the MSC connecting to these nodes to handle packet switch data. VLR, Visitor Location Register. It is a dynamic database in mobile networking subsystem (NSS) that stores temporary information about subscribers who are currently roaming within a particular mobile switching center (MSC's) area. VLR standards for visitor location register. It is a dynamical database in a mobile networks NSS, network subsystem, that stores temporary information about subscribers who are currently roaming with a particular MSC mobile switching center area. Here is the breakdown of it is the key function. Temporary storage of subscriber data. When the subscriber roaming into the new MSC area, a copy of relevant information from their home location register (HLR) is transferred to the VLR of that MSC. This information includes the subscriber phone numbers, service profile, and current location. This avoids constantly querying the HLR, which is a geographical distance and potentially overloaded database. Location tracking. The VLR helps track the location of the subscriber within the MSC area. This is crucial for routing calls and managing handovers as the subscriber moves between cells within that area. Call processing. The MSC uses the information VLR to process the call subscriber within its area. This includes sets up calls, routing calls, and managing calls, call handovers. Temporary data. The information stored to VLR is temporarily when the subscriber leaves the MSC area. The information is removed from the VLR. This keeps the VLR size manageable and prevents it from becoming overloads. HLR, Home Location Register. HLR stands for Home Location Register. It's a central database in a mobile networks subsystem (NSS) that stores permanently information about each subscriber on the network. Think of it as the network's permanent address book for all its users. Here is the breakdown of the key information stored in HLR. Subscriber identifier. This includes the subscriber phone number, MSISDN, IMSI, International Mobile Subscriber Identifier, and other unacute identifiers. Service profile. This defines the service subscriber to by the user, such as voice calls, SMS, data, service, and any special features. Location information. This indicates the subscriber home mobile switching center (MSC), which is the MSC response for the handling calls when the subscriber is in their home area. Security information. This includes information related to authentication and security, such as encryption keys and authentication parameters. Other subscriber data. This can include billing information, call details, records, CDRs, and other relevant data. Key function of the HLR. Subscriber identification and authentication. The HLR is used to verify the identifier or subscriber when they access the network. Service provision. The HLR provides information about the services subscriber to buy each subscriber, allowing the network to provide the appropriate services. Location tracking. While not directly tracking the subscriber current location, that is the VLR's job. The HLR stores the subscriber home (MSC), which is essentially for location management. Roaming support. The HLR plays crucial roles in supporting roaming. When a subscriber roams to another network, the HLR provides the necessary information to visit the network. Billing and charging. The HLR often contains information related to billing and charging, although this might be handled by separated databases in some networks architectures. Authentication Center (IUC). Authentication Center, Standard Authentication Center. It's a security component within a mobile network subsystem (NSS), responsible for verifying the identity of a mobile device and generating encryption keys for secure communication. It's a crucial part of ensuring the security and integrity of network. Authentication database. The authentication database stores information about mobile subscribers, including their authentication keys and encryption keys. Key generation. The key generation component generates and manages encryption keys for mobile subscribers. Key distribution. The key distribution component distributes encryption keys to mobile subscribers and network elements. Security module. The security module provides a secure environment for storing and managing sensitive information about mobile subscribers. Authentication Center checks the information stored in the subscriber identifier module that is the SIM card for correspondence with his own register. If the data provides to identical authentication of subscriber is successful, and it gives to enter to the network. Equipment Identity Register (EIR). It is a database within mobile network that stores information about the international mobile equipment identity (IMEI) numbers of mobile device. The IMEI is the unique 15-digit number that identifies each individual mobile phones. The primary function of the EIR is to help prevent the use of stolen or blacklisted mobile phones. How it works. IMEI storage. The EIR contains database of IMEI numbers. Each entry may indicate whether a device is valid, stolen, or otherwise blacklisted. This information is typically provided by mobile network operators and law enforcement agencies. IMEI checking. When a mobile device attempts to connect to the network checks the device IMEI against the EIR. If the IMEI is found in the EIR and marked as a stolen or blacklisted, the network will typically block the device from accessing the network. Security enhancement. By blocking blacklisted device, the EIR helps to reduce mobile phones theft or fraud. It makes it more difficult for thieves to use stolen phones on the network. Network security. The EIR contributes to the overall security of the mobile network by preventing unauthorized access and the use of compromised device. Let's continue to break down for the frequency band. Here is the breakdown details provided regarding GSM 900 MHz frequency band. For uplink frequency band, this is the frequency range used from communication from mobile device, I mean mobile station, to the base station. For GSM 900, this range is 890 MHz to 915 MHz. For downlink, this is the frequency range used for communication from the base station to the mobile device for GSM 900. The range is 935 MHz to 960 MHz. What is the channel spacing? The frequency channels are spaced 2 kHz apart. This means that each channel occupies a bandwidth of 200 kHz with the allocated spectrum. What is the bandwidth calculation? The total bandwidth for the uplink and downlink is 25 MHz each one. How we calculate? If we take 915 MHz to minus 819 MHz, we have 25 MHz. This is for calculation. To determine the number of channels available, you divide the total bandwidth by the channel spacing. Here it is calculated 25 MHz divided 0.2 MHz. Totally, we have 125 channels. This calculation shows that there are 25 channels available for both uplink and downlink. Practical, how we use. In practical, not all 125 channels are available for general use. Some channels are reserved for essential function, such as control, synchronization, or guard purpose. Therefore, only we have 24 channel pairs, also known as RFC and absolute radio frequency channel numbers, are typically reference for the voice and data services. Let's continue to 118 MHz frequency band. The uplink frequency range is 1710 MHz to 1785 MHz, resulting in the total bandwidth of 75 MHz. For downlink, frequency range from 1805 MHz to 1880 MHz, also resulting in a total bandwidth of 75 MHz. What is the channel spacing? Channel in GSM 18 are spaced 2 kHz apart. This spacing allows multiple channels to fit within the allocated bandwidth. How we calculate? The calculation for the number of channels based on uplink bandwidth. For example, 75 MHz divided 0.2. It's totally we have 375 channels. This means that theoretically we have 375 channels could be able in each band, uplink and downlink. And the standardization is, however, in the practice, standardization absolutely radio frequency channel numeric RFCN system result in 374 channels available for mobile traffic in each direction. This reduce is due to some channels begin reserved for control, synchronization, and guard purpose. Finally, therefore, while the theoretical calculation suggests 375 channels, the practical application and standardization lead to commonly referenced number of 374 channels or channel pairs available for user traffic channel in GSM 18 networks. Let's continue to 19 MHz frequency band. What's the uplink frequency? This is the frequency range used for communication for the mobile device, mobile station to base station, which spans from 1850 MHz to 1010 MHz. And what is the downlink? This is the frequency range used for communication from base station to mobile device, which spans from 1930 MHz to 1099 MHz. Bandwidth count. How we calculate the bandwidth? The total bandwidth for uplink is calculated as 1910 MHz minus 1850 MHz, nearly 60 MHz. The downlink also has bandwidth same. Calculation spacing in GSM 1900 channels are spaced 2 kHz apart, which allows the multiple channels with the allocated bandwidth. Channel calculation. The number of channels available can be calculated as 60 MHz divided 0.2 MHz, nearly 300 channels. This calculation indicated that there are theoretically 300 channels available for both uplink and downlink. Practical usage. In actual network implementation, some channels are reserved for essentially functions such as control, synchronization, and guard purpose. As a result, the number of channels available for user traffic may be slightly lower than the theoretically maximum of 300 channels. Summary, therefore, while the theoretical calculation suggests that 300 channels are available in GSM 1900, practical consideration typically reduce this number, affecting the actual capacity for user traffic. Time division multiple access, TDMA. TDMA is a key technology that enables multiple users to share the same frequency channel by dividing the channel into the time slot. Time slots. Each channel is divided into the several time slots in the GSM. Each channel can be split into 8 time slots, allowing up 8 users to communicate over the same frequency simulation. User assignment. Each user is assigned a specific time slot during which they can transmit or receive data. This means that user takes turns using channel efficiently sharing the bandwidth. Synchronization. The band synchronization controls the timing of time slot and ensure that mobile stations are synchronized to their assigned to time slot. This synchronization crucially to prevent overlap and interference between users. Frequency division multiple access FTMA. It is a method that uses telecommunication to allow multiple users to share single communication channel. It achieves this by dividing the available bandwidth into the multiple non-overlapping frequency channels. Each user is then assigned a unique frequency channel for their communication. Bandwidth division. Imagine a wide river. The total bandwidth FTMA divided this river into the several smaller separate streams, frequency channels. Unique channels. Each user gets their own stream, frequency channel, to use. They don't share the same stream with anyone else. Transmission. Because each user has their own dedicated channels, multiple users can transmit data at the same time without interfering with each other. This is unlike other methods where users take turns using the same channel. Analog. Think of like multiple radio stations broadcasting at the same time. Each station broadcasts on different frequency channels, so you can listen to multiple stations without interference. Limitation. While simple to implement, FTMA is less efficient than some newer techniques. If one user signal is strong, it can still cause interference on nearby frequency, even if they are technically separate channels. Also, it is not as flexible in allocated resource as some other methods. Time division multiple access (TDMA). Digital modulation techniques used in wireless communication to allow multiple users to share the same frequency channel, unlike FTMA, which divides the frequency spectrum. TDMA divided the time each user gets allocated specific time slot within a frame to transmit their data. All users share the same frequency. The channel time is divided into the recurring frames, and each frame is further divided into the time slot. Each user is assigned one or more time slot within this frame. While multiple users share the same frequency, they transmit at different times, and only one user transmits at any given time slot. This avoids the interference. Precise synchronization is crucial in TDMA to ensure that users transmit and receive data in their allocated time slot without overlapping. TDMA is more spectrally efficient than FTMA because multiple users can share the same frequency. However, it is less efficient than CDMA, code division multiple access. The key difference between FTMA, frequency division multiple access, and TDMA, time division multiple access, lies in how they allow multiple users share communication channel. FTMA assigns each user a different frequency channel. Users transmit simultaneously on their assigned frequencies. Think of it like separate radio stations broadcasting at the same time on the different frequency. TDMA divides the time. TDMA assigns each user different time slot with the same frequency channel. Users transmit sequentially, taking turns within the allocated time slots. Think of it like multiple people taking turns speaking on the same phone line. The calculation 8 time slot 0.57 millisecond time slot 4 equals 4.62 millisecond describe the structure of TDMA, time division multiple access frame. This is a method for multiple users share a single communication channel instead of using different frequencies like FDMA. TDMA divides the time into the slots. These are short periods within a larger frame only one user can transmit during a single time slot. A frame is repeating cycle time slot. After the last time slot, the cycle repeats. This indicates that the TDMA frame in question is divided into the 8 individual time slots, 0.57 millisecond time slots. This means each time slot lasts 0.57 milliseconds. Imagine a pie. The frame cut into 8 slices. Each slice takes 0.57 milliseconds to eat transmit data. The total time to eat the whole pie complete the frame is 4.62 milliseconds. The mobile station International Subscribers Directory Number (MSISTN) is the international standardization number used to identify a specific mobile phone subscriber on a global scale. It is essentially your mobile phone number, but with a more formal and techniques design. The international part of signification that the number is designed to work across international borders. This means you can call and be called from anywhere in the world, provided the number is correctly formatted and routing is possibility. This refers to individual or entity that owns and uses mobile phone services. Directory numbers. This is the number used to locate the subscriber within the telephone network. It is the number you dial to reach them. Mobile station. This specification that the number is associated with mobile phones as opposite to fixed line uh, telephone. Number format. MSISTN typically follow a specific number, often starting with a country code, following by national sanctification number. For example, +1 555 1 2 3 4 5 6 7. This is a North America number. The plus indicates an international number 1 is the country code for the United States and Canada and 555 1 2 4 5 6 7, for example, is the subscriber number. Plus 44, if the starting plus 45, 4, then is the UAK code. It means UAK codes. Unique identifier. Each MSISTN unique within a country and ideally globally. This ensures that calls are routed correctly to intent received. While you use MSISTN to make calls, the network uses it internally for routing, billing, and other network functionalities. It is a key identifier used by network to locate and connecting to you. MSISDN accused that mobile country code MCC plus NDC network destination code plus MSISDN mobile subscriber identifier number. This 234 number is stored under the home location register HLR. The remaining identifier 56789 is associated with subscriber. The last two digits 89, which represent the subscriber, fax data, service, etc. International Mobile Subscriber Identity IMSI is a unique 15-digit number that identifies a specific subscriber at GSM, UMTS, or LTE mobile networks. Think of it as a secret international identification number on your SIM card, unlike your phone number, MSISDN. The MSIS is not something you typically see used directly. It used behind the scenes by the network for various purposes. The international aspect means it's designed to work across different countries and mobile networks operators. This is a crucial roaming. Mobile subscriber identifies a specific individual or identity subscribe to mobile network services. Identity is a unique identifier, means no two subscribers have the same IMSI. The IMSI is different from your phone number, MSISDN. Your phone number is what you give to others to call you. The IMSI is not internal identifier used by network. The IMSI is stored on your SIM card. When you insert your SIM card into the phone phone uses the MSISD to identify you to network. Key uses. Authentication is the network users. The IMSI is authenticate your device and verify your identify when you connected. Location tracking. The network uses the IMSI to track your location in conjunction with other information. Roaming. When you roam to different network, your IMSI is used to identify you and allow to access services. Security. The IMSI plays role in various security mechanisms with the network. You can see some examples for IMSI numbers. Mobile switching center handover. If the mobile subscriber make a call, moves from the one MSC to another that covered by the different VLR MSC, it means that entire MSC handover is required. It means that transfer of the call from current servicing MSC or anchor MSC to the new MSC target. MSC, the anchor MSC, responsibility of all core activities. So he must be know where the root call. Target MSC sent to handover home handover numbers to anchor MSC. Using this number, it can be create a connection to the target MSC. Temporary mobile subscriber identity (TMZ). It is a temporary identifier assigned to mobile subscriber when roam into the different mobile network. When you travel to different country or region and use the mobile phone, you are roaming onto the different network operators infrastructure. Your home network needs a way to identify you to foreign network. Your home network provides the visiting networking with your TMZ. This temporary identifier allows the visiting network to authenticate you provides you with these services while you are roaming. Using temporarily identify helps enhance security. The visiting network doesn't need to access your permanent TIMSI, international mobile subscriber identity, reducing risk of security breaches. The TIMSI is only valid for duration of your roaming session. Once you return to your home network covers coverage your area, the TIMSI is no longer needed. The TIMSI is derived from your permanently IMSI. The home network uses algorithms to generate the TIMSI, ensure it is unique for each roaming session. TIMSI is generated to VLR, Limited Hosting Network for the first location update, then linked it to IMSI. It sends to data security reasons. Then TIMSI sent MS. It is temporarily mobile users. When the subscriber roams into the new network coverage area, uh, their mobile device initiates a location update procedure. This procedure informs the visited network of subscribers. The subscriber home network is involved into the process. It's responsible for providing the necessary information to visited network, including TIMSI. The home network generates the TIMSI for the specific roaming session. This TIMSI unique to the particular visited network. Location update with TIMSI. During the location update, the subscriber mobile device transmits the TIMSI to the visited network infrastructure. The identifies the subscriber to visit network, the location information. The current SAM is also transmitted. The visited network uses the TIMSI along with other security information by the home network to authenticate the subscriber and ensure secure communication. Once authenticated, the visited network can provide subscribers with the services like voice calls and data access. Location tracking. The visited network uses the location information provided during the location update along with the TIMSI to track subscriber location within its network. This is essential for call routing and handover management. When the subscriber leaves the visited network coverage area, the TIMSI is no longer need to TIMSI is relevant and location information is removed from the visited database. International Mobile Equipment Identifier (IMEI) is a unique 15-digit number that identifies a specific mobile phone or other mobile device. It is like a serial number for your phone, permanently attached into the hardware. Each IMEI is unique worldwide. No two phones have same IMEI. The IMEI is permanently associated with the device hardware. It cannot be changed. The IMEI is typically stored in the phone's memory and can be accessed the dialing star #06 hashtag. On most phones, can you can find your IMEI numbers. When you turn your phones, the network uses the IMEI to identify and register your device. The IMEI is used to identify stolen and blacklisted phones. If a phone is reported stolen, its IMEI can be added to database, the Equipment Identifier Register or EIR, preventing it from connection to the network. Tracking. While not primarily used for real-time tracking, to IMEI can be used to trace phone's location if it's reported stolen. The IMEI is used to identify the specific models and manufacturer of the phones. IMSI, International Mobile Subscriber Identifier, this identifies the subscriber, not the device. It is associated with the SIM card. MSIST and Mobile Station International Subscriber Directory number is your phone number. In short, IMEI is crucial identifier for your mobile device, playing a key in network registration, security, and tracking. It's a permanent and ununique identifier attached into your phone hardware. CGI, Cell Global Identity. The Cell Global Identity (CGI) is a ununique identifier for the specific cell site base station within a mobile network. It's used to precise location tracking and various other network management. Each cell site in a mobile network has a unique CGI. This allows the network pinpoint the exact location of mobile device. This CGI is typically composite of two parts. Location area code, LAC, identify a larger geographical area contains multiple cells. Cell identity, CI, identifies the specific cell site within the location area. Location tracking, the primary use of the CGI is for precise location tracking. When a mobile device connects to cell site, the network records the CGI, providing the exact location of the device. CGI are used for various network management tasks such as optimization, network coverage, identifying areas with poor signal strength, and troubleshooting network issues. CGI are used during handovers, when a call is transferred from one cell to another to ensure seamless connectivity. CGI are included in data reports that provides information about network usage and performance. In short, the CGI provides the precise location identifier for a cell site within the mobile network. It's a crucial piece of information for location tracking, network management, and ensure the smooth operation of the mobile network. Location updates. LA. A location update is a procedure in mobile network where a mobile device informs the network of its current location. This is a crucial process for several reasons. For example, call routing. When someone calls you, the network needs to know where to find you to route the call to your mobile device. Location update keeps the network information of your current location. Handover management. As you move around your mobile device, switch between different cell towers, different cells. Location updates help to network manage these handovers seamlessly and ensuring that your call doesn't drop. Roaming. When you travel a different area or country, location update inform your home network and visit location of your location, enabling roaming services. Location-based services. Many location-based services like GPS navigation rely on location updated provide accurate location information. Billing. Location updates can be used for the billing purpose, particularly for roaming services. Emergency services. In emergency situations, location updates are critical for dispatching emergency services to your location. How it works. Mobile device periodically send location updates message to the network. This message typically including information such as mobile identity, the device unique definer IMSI or TIMSI. Location information. The current cell ID, location area, identity, LAI, and possibility more precise location data. The frequency of location updates depends on various factors, including the mobile device's movement and the network's configuration. The network uses this information maintain and update record of the device's location. In short location updates area, fundamentals processing in mobile networks that ensure calls and be routed correctly, and those are managed seamlessly, and location-based services can function. They are essentially for smooth operation of the mobile network.
Fire, IMSI or TMSI. Location information, the current cell ID, location area identity, LAI, and possibly more precise location data. The frequency of location updates depends on various factors, including the mobile device's movement and the network's configuration. The network uses this information to maintain an up-to-date record of the device's location. In short, location updates are a fundamental process in mobile networks that ensures calls can be routed correctly, handovers are managed seamlessly, and location-based services can function accurately. They are essential for the smooth operation of the mobile network. Simplified 2G 3G location update call flow, mobile station, MS, initiates. The mobile device, your phone, periodically determines that a location update is needed, based on timers or movement. This might be triggered by a change in location area, LA, or after a period of inactivity. Location update request. The MS sends a location update request message to the network. This message includes the mobile's identity, IMSI, and its current location information, e.g., location area identity, LAI, cell identity, C. Base station, BS, to base station controller, BSC. The request is passed from the base station, cell tower, to the base station controller, BSC. BSC to mobile switching center, MSC. The BSC forwards the request to the mobile switching center, MSC. The core network element responsible for switching calls and managing mobility. MSC to home location register, HLR. The MSC queries the home location register, HLR. A central database containing permanent subscriber information to verify the subscriber's identity and retrieve relevant data. HLR response. The HLR responds to the MSC with the subscriber's information, including the subscriber's profile and any necessary security parameters. MSC to VLR, if applicable, if the subscriber is roaming. The MSC might update the visitor location register, VLR, in the visited network with the subscriber's information. MSC to BSC BS. The MSC sends a response back to the BSC, which then forwards it to the base station. Location update acknowledgement. The base station sends an acknowledgement message to the mobile device, confirming the successful location update. Key considerations. Timing. Location updates happen periodically, not continuously. The frequency depends on factors like network configuration and the mobile device's movement. Security. Authentication and security measures are involved to protect against unauthorized access and ensure the integrity of the location update process. Network generation. The specific messages and procedures involved can vary slightly depending on the network generation, 2G, 3G, 4G, 5G. Newer generations often use more efficient and sophisticated location management techniques. Simplified view. This is a simplified representation. The actual call flow can be more complex. involving additional network elements and procedures. This call flow ensures that the network always has an up-to-date record of the mobile device's location, enabling efficient call routing, handover management, and other network services.
Authentication. The mobile device MS initiates an attach procedure to network typically when it powers on or enters a new coverage area. This involves sending a attach request message. IMSI transmission. As a part of the attach request, the mobile device SIM card transmits the international mobile subscriber, IMSI, the network. Authentication request to AUC. The network is core network element, typically the mobile switching center MSC, forward the IMSI to the authentication center AUC. The AUC is response for verifying the subscriber identity. Rand generation by authentication. Authentication generates a random number, rand, and other cipheronic parameters, stress, SINET response, like. Challenge transmission to MS. The network sends to rand and other parameter to mobile device. This is the challenge part of the authentication process. Computation on the SIM. The mobile device SIM card uses the receive rand along with a secret key I stored securely and the SIM. Perform the cryptographic computation. This computation generates a response, typically on stress. Response transmission to network. The mobile device sends the computed response, stress, back to the network. Verification by authentication. The authentication receives the response and verify it against the expected value based on rand and the subscriber secret key I stored in the VLR home location register. Authentication success failure. If the verification is successful, the authentication is successfully. If not, authentication fails and the device is denied to access. Upon successful authentication, the AUC generates the session key C. This key is used to encrypt sub-sequenced communication between the mobile device and network, ensure confidentiality and integrity. Security context establishment. The session key is distributed to mobile device and network elements involved the communication. This establishment secure context for subsequent communication. You can see here the mobile sent to SRES and the mobile station sent to RAND, and the RAND and stress key C is coming from the HLR AUC, and the triplet frog and key C stress is creating bar authentication center, and its response for the authentication triplet from the MSC to HLR VLR. If the SRES and SRES mobile station to authentication center is equal, then connection is completed, and mobile is creating RAND, SRES, and key C, and SIM card having got A3, A8, and key I. Key I and RAND is equals to A3, and it is SRES. Key I and RAND is A8. It is creating for key C. Common channel. In GSM, Global System for Mobile Communication Network, common channels are radio channels used for broadcasting information to all mobile stations. within a cell. This is in contrast to dedicated channels, which are assigned to exclusive to single mobile station for specific communication station. Common channel provide essentially information needed for the mobile station to operate correctly within the cell. They are crucial for initial network access, synchronization, and receiving system information. Key common channels including frequency correction channel (FCCH) provides a pilot signal that allows mobile station to measure and correct for frequency offset between the base station and the mobile device. This ensures accurate reception. Synchronization channel (SCH) transmission timing information necessary for synchronization between the mobile station and the base station. This is essentially for the time division multiple access TDMA techniques used in GSM. Broadcast Control Channel (BCCH) carrier system information such as cell identifier, location area code, LAC, neighboring cell information, and other parameters needed by mobile station to operate within the cell. This is crucial for the mobile device to know which cell it is on, how to connect to the network. Paging channel PCH used to page mobile station when someone calls a mobile phone. The network uses PCH to send a paging message to the phone, alerting it to an incoming call. Note that while used in individual calls, it is still a common channel because it is broadcast to all phones in the cell. The phone only responds if the paging message is addressed to it. Cell Broadcast Channel (CBCH) used to transmit cell broadcast message to all mobile stations within a cell. This message can include public service announcement, emergency alerts, or other information. These common channels are essentially for initial setup and ongoing operation of a GSM. They provide the necessary information for mobile device to connect synchronization and receive system wide information. They are broadcast continuously, allowing the mobile devices to easily access this information. FCCH (Frequency Correction Channel) is a common control channel in GSM global system for mobile networks. Its primary purpose is to provide a pilot signal that allows mobile station your phone to accurately measure and correct for any frequency offset between the mobile station receiver and the base station transmitter. Frequency offset. Due to various factors like Doppler shift caused by movement oscillators occurs in both the mobile device and the base station and propagation effect, there can be a slight difference in frequency between the signal transmitted by the base station and the signal received by the mobile device. This difference is called the frequency offset. Pilot signal. The FCC transmission a continuous stable pilot signal. This signal acts as a reference for the mobile device. Frequency measurement. The mobile devices receive the continuously monitors the FCC signal and measure the frequency difference between the received signal and its own internal oscillator. Frequency correction based on the measurement frequency offset. The mobile device receiver adjusts its frequency to compensate for the difference. This ensures that the mobile device receives the signal from the base station accurately. Accurate frequency correction is crucial for reliable communication. Without it, the received signal will be distorted, leading to poor call quality, data error, and potentially connection failure. The FCCH is the first channel a mobile device, typically occurring when searching for mobile Continuous transmission. The FCCH transmission continuously providing a constant reference signal for frequency correction. In short, the FCCH is a fundamental channel in GSM networks that ensure accurate frequency synchronization between the mobile device and the base station, enabling the reliable communication. It's a critical component for maintaining the quality of radio link. Synchronization channel (SCH). In GSM Global Mobile Communication, SCH standard for synchronization channel. It's a common control channel that broadcasting timing information, crucial for the proper operation of the network, particularly for the time division multiple access (TDMA) techniques used in GSM. TDM synchronization. GSM used TDMA, meaning multiple users share the same frequency channel but are assigned a different time slot. Kai's timing is essentially to avoid the collision between users. Transmission. The stage provides the necessary timing information to synchronize the mobile device with the base station. Frame synchronization. Exchange transmits synchronization signal that allow mobile device to align to their internal clocks with the base station timing. This ensures that mobile device can correctly decode the data receiving. Timing advance. This SCH also helps to adjusting the timing advance. Timing advance is a mechanism to compensate for the propagation delay for the signal between the base station and the mobile device. This is particularly important for the device further away from the base station. Continuous transmission. The SCH transmission continues to providing constant timing reference for the mobile devices. Without accurate synchronization, providing SCH TDMA wouldn't work efficiently. Transmission would be overlap, causing interference and data corruption. The SCH is therefore a fundamental component of the GSM air interface, ensure the reliable and efficient operation of the TDMA system. Broadcast Control Channel (BCCH) is a crucial command control channel in GSM global system for mobile networks. It continuously broadcasts essential system information to all mobile station (MS) within a cell. This information is vital for mobile device to connect to any operate within the network. System information dissemination. The BCCH broadcasts system information allowing the mobile device identify the cell, determine the cell ID and location area lock, access the network, obtain parameters needed to access the network, such as the frequencies used, the different channels, and network operation fundamentals. Find the neighbor cell, discovering the information about the neighboring cell to facilitate the handovers when the mobile device moves. Obtain other crucial parameters. This includes information about power control, frequency hopping sequence, and other operational details. Continuous broadcasting. The BCCH transmits the continuously ensuring the mobile device have access to latest information. Mobile station acquisition. When a mobile device powers on enters a new cell, it uses the BCCH obtain the necessary information to connect to network. Network management. The BCCH plays a role in network management by providing information about the cell status and configuration. In short, the BCCH is a fundamental channel in GSM network, providing the essential network information that allows mobile device correct, operate, and roaming with the network. It is continuous to broadcast and ensure that mobile device always have access to the information they needed. Cell broadcast control channel is a common control channel GSM network for mobile, used to transmit short messages to all mobile stations with a specific cell. Unlike the BCCH broadcast channel, which is provide the system information, CBCH is used to dissemination public information or alerts. One-to-many communication. The CBCH facility one-to-many communication sending the same message to all mobile devices with a cell coverage area. Public information dissemination. It is primary purpose to broadcast public information such as emergency alert, warning about natural disasters, weather or other emergency, public service announcements. If information about traffic condition, public health advisors or other important announcement. Commercial messages. Truth less common and often subject to regulation. No user interaction required. Unlike a typical SMS message, broadcast messages are received passively by mobile device without requiring an user interaction and subscription. Reliability. Broadcast messages are designed to be reliable and ensure that important information reaches as many devices as possible. Geographical target. Cell broadcasting message can be targeted to specific geographical area, allowing for localization alerts and announcements. In contrast, on the BCCH, which provides essential system information for network operation. The CBCH is dedicated to delivering public information and alerts to mobile device within a cell coverage area. This makes it a valuable tool for emergency services and public safety. Common Control Channel (CCCH) in GSM in terms Common Control Channel isn't a specific individual name channel like a BCCH or SCH instead. It is a general term referring a group of channels used to control signaling that's accessible to all mobile stations within SL. This channel is a handle various control functions necessary for the operation of the network. Common control channels are used for tasks that don't involve the transmission of user data, voice or data. Think of it as a category encompassing several channels that share the characteristic of being able to all mobile stations in a cell for control purpose. Specific channels that fall under this umbrella including BCC channel, broadcast channel provides the system information to all mobile stations. SCH provides the timing information for synchronization. PCH paging channel used to page mobile relation to alert them incoming calls. Random access channel used to mobile station to initiation communication with the base station. Access ground channel ACCH used to base station ground access to dedicated channel. While these channels have a specific name and functionality, they all share the common characteristic of being available for all mobile stations within a cell for control purpose. Hence, the general terms. Common control channel. The term is used to broadly categorize these channels that handle control signaling rather than user data. Paging channel. The paging channel PCH is a common control channel in GSM system for mobile communication network. Its a primary function is to transmit paging messages to alert mobile station, your phones, about incoming calls or other network events. While the PCH is a broadcast channel sending information to all devices in a cell, the paging messages themselves are addressed to specific mobile station. The network uses the mobile station identify IMSI or TIMSI to target paging message. Alerting mechanism. When the call is made to mobile phone, the network user PCH to send paging message to mobile device within the cell where the subscriber is located. This alerts the mobile device that it has an incoming calls. Call setup initiation. The paging message initiates to call setup process if the mobile device is switched on and within range. It responds to the paging message, initiating to step to establishment a connection. Other network events. The PCH isn't only used to incoming calls. It can also used to alert device devices about other network events, such as a short message (SMS) or other type signaling. Frequency hopping. GSM network that use frequency hopping, the PCH may hop between different frequencies according to predefined sequence. Shared resource. The PCH is a shared resource with a cell. Multiple paging messages can be transmitted to PCH, but they are carefully managed to avoid the collision. In short, the PCH is a crucial component of GSM network, acting as an alerting mechanism to notify the mobile device of incoming calls or other important network events. It is a shared broadcast channel that efficiently targets individual mobile device using their unique identifier. Random access channel (RACH) is a crucial channel in the GSM networks that allows the mobile stations to initiate communication with the base station. It's used when a mobile device needs to send a message to network, such as initial call sending on SMS or requesting network access. RAT is used by a mobile device to initiate communication with the networks. It is the first step in establishment connection. The name random access reflects the fact that mobile device can access the RAT at any time without priority coordination with the base station. However, this random access is managed to avoid collision. Be- uh, Collision avoidance, because multiple mobile devices might be tried to access the range. Simultaneously, mechanisms are in place to prevent collisions. This mechanism typically involve techniques like slotted Aloha or similar protocols. When a mobile device transmits on the range, its sending message indicates its desire to communicate with the networks. This message includes mobile device identity, IMSI or TIMSI. If the base station receives the access request successfully without collision, it responds by assigning the mobile device dedicated channel. For example, a dedicated channel SSH or further. Access to RAT is content-based, meaning that mobile device component for access to the channel. This is different from the dedicated channel, which are assigned exclusively to single mobile device. In the short, the RAT is an entry point for mobile device to initiate communication with the GSM network. It's a contention-based channel with the mechanism to manage access and prevent collisions, allowing the mobile device to request network access and receive an assignment to a dedicated channel for further communication. Access Grant Channel AGCH. Access Grant channel is a common control channel in GSM network. Its sole purpose is to provide a response from the base station to mobile station request access to dedicated channel. This happens after the mobile station has successfully transmitted a request on the random access channel (RACH). RACH access request, a mobile station initiated communicate by transmit on access the request on RACH. The network use mechanism like slots Aloha to manage multiple access requests on the RACH and avoid collision. If the base station successfully received the access request, it allocated resource to the response. The base station transmits a message on the access grant channel to grant access to mobile station. This message contains information such as assignment of dedication channel, specific the frequency and the time slot dedication channel, like SSH, that the mobile station should use the further communication. Timing advance. Instructions to adjust the timing of transmit to compensate for propagation delay. Other parameters. Other parameters necessary to establishing the communication link. Dedicated channel usage. After receiving the access grant channel AGCH, the mobile station switch to the assign the dedicated channel to continue the communication process, like call setup or data transmission. The access grant channel is a short critical link to communication process. It's a base station response to mobile device request to mobile devices used to network providing the necessary information for the mobile device to proceed with its communication. Without a successful access grant channel response, the mobile device cannot proceed with its communication request. Dedicated channel. In GSM networks, dedicated channels are radio channels assigned exclusively to a single mobile station for the duration of a call or data session. This is contrast to common channels, which are shared by all mobile stations within SM. Dedicated channel provides a guaranteed and uninterrupted communication path for duration of the connection. Exclusive use. Unlike common channel, dedicated channels are not shared a single mobile station, has exclusive use of the assigned channel for the duration of its communication session. This ensures uninterrupted communication and avoid the interference from other users. GSM uses several types of dedicated channel primary and control signaling traffic transmission. STCH, stand-alone dedicated channel, STCH, used for signaling during the call setup and other control functionalities. They handle initial setup and teardown of call. Slow association, SACCH, used for slow rate control signaling such as a power control, adjustment, and handover information. They maintain the ongoing connection. Fast association control, FACCH, used for the fast rate control signaling primary during the handovers. They ensure seamless transmission between cells. Traffic channel, TCH. These carry the actual voice and data traffic during a call or data session. They come in different rates, full rate or half rate. Channel assignment. The network assigns the dedicated channel to a mobile station as needed. The assignment is dynamic, meaning that channels are allocated and released as communication sessions start and end. Resource allocation. The assignment of dedicated channel involves an allocation specific frequency and time slot within the available radio spectrum. Improve quality service. The exclusive use of dedicated channel generally results in improvement quality of service compared to common channels, as there is no connection or interference from other users. In short, dedicated channels provide a guaranteed high-quality communication path for individual mobile stations, ensuring reliable voice and data transmission during calls and data sessions. They are essential for quality of service in GSM networks. STCCH, standalone dedicated control channel, is a type of dedicated channel in GSM networks, unlike association control channels, SACH and FACH, which are used alongside traffic channel. The STCH is used independently for control signaling. It is primarily used during the setup and teardown phases of call or data session. Call setup. The SSH plays a crucial role in the initial stages of call setup. It's used to exchange signaling message between the mobile station and network establishment connection. Call release. Similarly, SSH is used to handle the release of call. The signaling message for disconnecting call are transmitted over the SSH. Other control function beside the call setup and release, SSH can be used for other control functionality such as registration. A mobile device uses the SSH to registration with the network. Location updates. The SSH can be used to transmit location update messages. Handover propagation. While handovers often the associated control channel SAECH, FACEH, the SSH might be involved in initial preparation stage. The key distinction of SSH is that it operated independently of traffic channel. It is not associated with the ongoing voice or data call. It is used specifically for control signaling. In short, the SSH is a dedicated channel used for independent control signaling (GSM) networks, primarily using the setup and release phases for the calls and for other control functions. It is standalone nature. Distinguishes it from the associated control channel SACCH and FACCH, which are used in conjunction with traffic channel. Slow Associated Control Channel (SACCH) is dedicated control channel in GSM networks that operates in conjunction with a traffic channel (TCH). It's used to transmit slow rate control information between the mobile station and the base station (BTS) during the active call session. The SSH is always associated with a specific traffic channel. It's operated concurrently with the TCH, allowing for the continuous control signaling while the user is engaged in a call or data transmission. The SSH is designed for slow rate signaling, meaning it is transmit information at a lower frequency compared to fast association. Power control. One of the primary functions of the SSH is to manage power control. The base station used the SSH to send power control common to mobile station. In interaction is just its transmission power. This helps optimize the signal quality and minimize interference with the other users. Handover management. The SSH is also used to convey information related to handovers. When a mobile station moves from one cell to another during a call, the SSH can facilitate a smooth transition by providing necessary handovers. Quality of servicing, QAS monitoring. The SSH can carry information related to quality of the communication link, allowing the network to monitor and adjustment parameters as needed to maintain and service quality. In addition, the power control and handover information, the SSH may transmit other types of control messages, such as updates on the mobile station status or request additional resources. In summary, the slow associated control channel SSH is a vital component of GSM networks that provides essentially control signaling during an active communication session. By operating alongside a traffic channel, the SSH enables effective power management, handover process, and overall maintenance of call quality ensure reliable user experience. Fast Associated Control Channel (FACCH). The FAST is a dedicated control channel in GSM networks that operates the conjunction with a traffic channel (TCH). It is designed to transmit control information at a faster rate compared to slow associated control channel (SACH). The FACH is primarily used for urgent signaling needs during an active call or data session. The FFCCH is always associated with a specific traffic channel. It operates concurrently with the TCH, allowing the rapid control signaling while the users engaged in a call or data transmission. The FCCH is designed for fast rate signaling, meaning it can transmit control messages more quickly than the SACCH. This is essentially for situations that require immediate attention or action. Handover commands. One of the primary functions of the FACCH is a facility handovers. When a mobile station moves from one cell to another during a call, the FACCH is used to send handover commands and instructions to ensure a seamless transition between cells. The FACCH can be used to transmit urgent control messages that requires immediate action, such as emergency alerts or critical updates related to ongoing communication. While the SSH typically handles regular power control commands, the FCCH can also be used to rapid power control adjustment when necessary, especially during handover situation. The FCCH may carry information related to quality of the communication link, allowing the network to make quickly adjustments to maintain services quality. The Fast Association Control Channel (FACCH) is a crucial component of GSM networks that provides fast and efficient control signaling during an active communication session by operating alongside a traffic channel. The FCCH enables the rapid handover process, urgent control message transmission, and efficient management of call quality, ensuring a reliable and high quality user.
Real-time GSM analysis.
From the checking BTS at the BSC level, we can see the following information. We gather data from the Nokia 2G sites level in the BSC. In Nokia terminology, BCF refers to BTS and BTS refers to cell. So please take note this important information. If you check here, you can see there are three cells under the BCF. One of the BCF cell name is Kemal 1, Kemal 2, and Kemal 3. And each have three cells. They are the same name. BCF is site. BCF is the site. This is a BCF 007. And this flexi H cabinets. You can see here the flexi TS cabinets. It means if there is a three cells, it will cover three. For example, the first cell is covering this area, the second cell is covering this area, the third cell is covering like this area. If you check the here flexi H cabinets type number 1001 is lag is 1121. You can see 1001 number is 1121. 21 is the cell ID. If you check here, you can see it. You can see each cell having three TRXs. For example, Kemal 1 cell under cell we have three TRXs: TRX1, TRX2, TRX3. We have four TRXs. Sorry, TRX4. And Kemal 2 has got four TRXs as well. 5, 6, 7, 8. And Kemal 3 has got 3 TRXs, 9, 10, 11, 12. So we can say when you say the configuration is 4, 4, 4. For example, if first one have got 2 TRX and second is 4 TRXs and third cell is 6 TRXs, then we can say S246. You can see the highlighted placement of frequencies. Each TRX has different frequencies. For example, TRX1 is 980, and it is for TDMA. This site is using for TDMA technology. And you can see the cell statement working. And if the TRX or site will be locked, you can see L. But now all the site is unlocked, so it will be unlocked. And here you can see the full lead and GPRX time slot in this area. If you check the first cell, TRX1 is holding BCCH frequency. You can see in the first one, it's holding for the BCCH frequency. It have, you remember the previous session, BCCH frequency must. So the first we put the first TRX is the BCCH frequency. If anything happen, it will goes to, for example, TRX2. You will not kill BCCH frequency until if the one TRX is and this TRX is fail, then BCCH will be down. Because if there is no BCCH frequency, it means the cell is not starting call or it's not working. You can see the TRX type as you can see the example of TRX type. For example, this is TCHD. This is all TCH. Sometimes we define the STCH, BCCH, depend on the TRXs. At the site level, we can observe the number of TRXs, power levels, modules, and other level details. One of the modules is named FHDB. You can see FHDB, which is connecting to S-mode cabinets. It will be connecting to AirScale cabinets. The output of this model is routed to RED. It's connecting to RED, remote electrical tilt. And it's connecting to GSM network as shown here. And it has 2 TRXs. This cell haven't got 2 TRXs. You can see here, and this is GSM, EGSM 900. Then you will see what's holding and which frequency band you will see for everything in that band. This module also should supporting 900 bands. So it means and GSM. So it means that if you use any modules, you have to use to same band and it have to comparing like that.